You open your laptop, type a web address, and hit enter. In a fraction of a second, a page of text, images, and video appears. We usually talk about this process like it is magic. We use words like the cloud, which makes it sound as if our photos and emails are just floating in the air around us, waiting to be pulled down by an invisible antenna. Underneath that metaphor sits a massive, tangible machine, a sprawling web of physical wires, thick cables, and warehouses full of blinking computers. Once you realize that every time you click a link, a real physical request has to travel across the planet and bring a physical piece of data back to your screen, the fact that it happens almost instantly becomes a lot more impressive. Before your computer can send a request to load a website, it has to figure out exactly where in the world that website actually lives. Your computer treats the name you typed like a listing in a master phone book. It sends a quick request to find the specific string of numbers associated with example.com, a translation process engineers call the domain name system, or DNS. That string of numbers is called an IP address. It acts exactly like a geographic GPS coordinate for the specific computer server that holds the website you want to look at. That server could be sitting in a building thousands of miles away, on the other side of the world, and your computer now has to send a physical message all the way there to ask for the page. This translation is the only thing standing between you and the need to manually memorize a unique 12-digit code for every single website you ever want to visit. Now we face an engineering problem. You cannot shove a giant digital request or a heavy video file through a thin wire all at once. It simply will not fit. So the data gets handed over to a set of rules called TCP. Think of TCP as the Internet's shipping and receiving department. To get your request through the wire, TCP chops the data up into tiny uniform puzzle pieces, known as packets. That IP address we looked up earlier, that destination number gets stamped onto the outside of every single one of those little packets. By breaking everything down into these small, identical pieces, the Internet can move massive amounts of information quickly and efficiently, without clogging the pipes. With the packets stamped and ready, they leave your house. They travel through your local Wi-Fi, into the cables in your wall, and out into the wires buried under your street. Along the way, they pass through devices called routers. Routers act as the intersections and traffic cops of the Internet. This drawing illustrates exactly how this works. You can see a packet making short hops from one router, marked by the red dots, to the next. At each stop, the router reads the destination address and passes the packet to the next closest intersection. These traffic cops talk to each other constantly. If one path is blocked by heavy traffic or a broken wire, the routers instantly redirect the packets to a different route to keep them moving. Because the directions are decided hop by hop rather than being planned out from the start, there is no single point of failure. If one cable goes dark, the system simply routes around it. Eventually, your packets reach the edge of the continent. To reach a server in another country, they have to cross the ocean. You might assume this is where satellites take over, beaming data through space. But nearly all international internet traffic actually travels by crossing through literal cables resting in the mud at the bottom of the ocean, placed there by massive specialized ships. Inside those cables are fiber optic strands. This image shows the inside of one of those cables. Each of those colored glass strands is designed to bounce pulses of light along its entire length. Your packets are converted into these light pulses, racing through the deep ocean floor at speeds that allow them to reach another continent in a fraction of a second. Our entire modern, wireless-feeling world relies totally on this intensely physical infrastructure, hidden underwater and exposed to everything from ship anchors to shifting tectonic plates. After crossing the globe, your tiny request packets finally arrive at the destination server. The server reads the message, which simply says, "Send me this website." Now the server has to reverse the whole process. It takes all the text, the images, and the code that make up the website, chops it up into millions of its own tiny packets, and fires them right back across the ocean. When all those millions of puzzle pieces finally rush back into your laptop, the TCP shipping department checks to make sure none were lost along the way and glues the picture back together on your screen. A round-trip journey spanning thousands of miles, broken into millions of pieces, passed through dozens of intersections, rebuilt completely, happening in a matter of milliseconds. Following this journey helps clear up two terms that people often use interchangeably: the Internet and the World Wide Web. The Internet is the physical infrastructure we just tracked. It is the miles of copper wires, the fiber optic cables, the routers, and the rules that allow them to talk to each other. It is the tracks and the trains. The web, on the other hand, is a service that was built to run on top of that physical infrastructure. This image shows an early web browser from the 1990s. The websites, the documents, the videos you watch, that is the web.